here. Gonna go live. Let's see if we can. Yep, no. There we go. So we're going to tear this fella down and see how it goes. Let me grab my screw gun. Now, as it stands, oh, we got two people on. Hi, everybody. So we're going to try this. I've never done this before. I'm using my camera phone, so I can't see comments, so bear with me. I won't be able to reply to you. And I'm technically at work, so I can't really stop either. So let's see how this goes and see what happens. So first things first, this projector is going to be used for parts, and so I need to get the parts out. It's a Sony VPL-HW45. It's a nice projector, slightly older but still decent. If this the live stream goes well, maybe I'll do another one. If it doesn't go well, I'll still probably do another one. Here's an original Sony lamp. Come on, focus. It's a 450-477. It's a 215 watt to 150 watt. I don't know the date code, but still good. Not a lot of crud down in there. Hi, Jay Orr. Thank you for watching. Let's see what happens. So let's see, I have one person watching. That's good. So again, we're going to try to get this fully torn down so I can get the main board out. That's the main thing I need, because I have another one that I need the main board for. Well, gonna have to get a longer bit for that. Let's see, that one, did I already do that? Yeah, I already did that. So I just have to get those guys in the front. Let's see, can I? Yeah, that'll reach. There we go. Let's get that one. Oh, two people watching now. Hi, other person. I wish I could still see the comments. I need to get something in front of me so I can read it while I'm doing this. Actually, I probably shouldn't distract myself. That's the air filter right there. I took the air filter off. It's got just dust. I keep dust and debris out. I'll set that over with the lamp and the lamp door. There we go. All right, I think there was one more screw that did not come out. Yep, there it is. Two. Get those guys. They go in the screw bin. So now, facing the screen, yep. There we go. The top comes off. Now we have to be careful. There's a keyboard connector right there. Unplug that. You can see there's the top. It's got all the mold marks. Looks like this one was made, I'm guessing that's March 2019. Polycarbonate, ABS, fiber reinforced, 40%. Let's set that over here. Now we're inside. This is an LCOS projector. There's no LCD panel or DLP chip. It uses a liquid crystal and silicone to make the picture, and it's pretty nice. It has a wireless from Untitled right there. There's actually a LAN port. You can see on the connectors, we just see, you know, IR, remote, HDMI, and then USB, but there's actually a LAN port hidden under here, which I'm curious to see if it actually works. See? Right there. Now, on the other one that I'm working on, I did see it light up, but I couldn't get to do anything, but that's because the other main board is actually bad, which is why this one's becoming a donor. So what I have to do is actually get all of this out, because unlike other Sonys, yeah, this bottom piece doesn't come off. The newer ones, this whole bottom comes out and you can get the main board out. But we just have to treat it like a bowl of ice cream and start digging our way in. So we'll just talk about the pieces as I take them out. The piece I'm taking out now, the first piece, this is the exhaust fan shroud. The lamp assembly's here. Air comes in that way, comes out, and exhausts here. And they have it like this to kind of quiet the airflow. It's really quiet. You can hear the fan when it comes on, but it's really, really quiet. And you'll hear it when we go to test it eventually on the other one. Let's see. Oh, I got oh, 2 people watching now. Man, I'm on fire. Alright, so that's loose, that's loose. You can, I don't recommend doing it this way. You can kind of work it out. Where's that other, there's one more screw down there. Right here, come on. There we go. There we go. So now this is loose, and it's kind of caught inside the plastic here. So I just kind of give it a little wobble, and then we can pop the exhaust shroud out. There's the exhaust fan. It spins that way, and then it sends the air through those baffles. You can see there's a whole bunch of baffles in here, and that helps quiet it down too. The whole goal is to slow down the air so the turbulence isn't making noise. Now we can see the main board, at least part of it. Well, let's see if... Oh, that was way too much. Oh, hey, Ed, thanks, man. Now I can see the comments a little better. So let's see. Next, let's go to... Let's get this part out. I'm really going to try and keep this all as single assemblies as much as possible. You see when I wiggle the back, the front wiggles with it. So I'm really going to try to just take everything out at once. But I think we'll take the front shroud off first, maybe. Let's see how that works. I've never actually torn one of these down before, so we're going to be learning together. Go that one, and then what do we have? Screw here, screw here. Actually, can I? There we are. And then this should nice. There's the shroud. All right, this is too close. Let me zoom out. Just like there we are. Let's go right there. We'll leave it at that. Every time I try to move it, it's like all the way in, all the way out. YouTube, your camera control to my phone stinks. But that's all right. So we got the front off. I see a fastener here. It's probably holding this fan assembly that's not part of the optics. I'm trying to find the pieces that are holding the optics in, and I don't know if you guys can see that right there. That's a big screw. And one thing I've learned with Sony is that they definitely use bigger screws when they need them. So that's probably a main, yeah, that's probably a main support screw. You can, hopefully this is focusing, you can see how big that is. There's going to be a few of those. Yep, there's one right here on the other side. Let's see if I can, not quite. Pardon me. Let's see, will this reach? There we are. We'll use this one. There we are. Go back to a more reasonable length. Okay, so those two main ones are out, and look at that. The back's moving already. That's pretty good. So let's see if we can find the screws in the front. Yep. Down here. Ooh. Flashlight? Yeah, there it is. Alright, so down. Dang it. Here, hold still. Down there. There's another one. And then right there, there's one. So I'll put the flashlight in my mouth. I can't reach. Alright, one. And then come on. Alright. Oh. It fell inside the other screw, but that's alright. The entire optic assembly should now be loose. Hey Tyler, what's up, man? Hey, like that. Alright, so that's loose. Now we have to disconnect some wires. So let's go over here. That one, because there's inside this can, we'll pop that open. That's where the power supply is. And I guess power control stuff. Let's see. I'm guessing that, just going by the construction. Yep. That's a heck of a piece of metal. I like that. And then there's the, I guess that's the, okay, this is the main power supply right here. So this is power in from AC. This is our line power from the wall coming in here. And then there's a fuse. Oh, that lifts off. That's nice. Then, let's see, this is power factor correction output, or for normal English, it's power to the ballast. That's like 400 volts to the ballast. We'll disconnect that. And then low voltage out right here to the main board and things. This thermal sensor, maybe? Yeah. Right there. Thermal sensor. So if that gets hot, I imagine it opens and then shuts the power supply down. So this has to come out. After I get that out, I should be pretty close to being able to lift the rest of the optics out, I think. Hey, we'll find out together. Really, I just unplug everything and it's going to come out one way or another. And the nice part is, as long as I don't destroy the main board, everything else is kind of extra. I mean, I don't plan on breaking anything, but, you know, famous last words and all that. Alright, so those are loose. Get that out. The reason I'm disconnecting the wires is really just to make it easier to lift everything out so nothing gets caught or pulled or, you know, damaged. The main board is my goal. Let's get this funny little wireless card out. disconnected. Oh, that's infrared to the front. All right, let's just unscrew that. So this is a little Untitled, I guess 2.4 gigahertz wireless adapter. That's kind of cool. All right, so then let's see, 1, 2, 3. Ooh, 5 people watching now. Holy mackerel. Very cool. Thanks for tuning in, everybody. I really appreciate it. I've never done one of these before, so I figured I'd give it a shot and see how big a fool I can make of myself without editing, especially since I'm moving to a new editing program. Let's see, that screw? Nope. Alright, so this board has to come out. I was hoping we could get to the screws holding the metal in without taking the board out, but nope. Yeah, we'll take that power supply out and we'll take a little closer look. Again, AC goes in here. PFC 380 comes out there. Oh, here we go. 380 at 255 watts, 16.7 at 3 amps, 6.2 at 2 amps, 6.2 at 0.6 amps, 3.3 at 20 milliamps, and that's it. And input voltage is 90 to 240, which is kind of curious. Or 100 to 240. I was kind of expecting to see 90 there because, you know, in Japan, I think they go down to 90 volts AC. Maybe they don't anymore. But I seem to recall that being one of the multi-voltage specs. All right, we got a little shield on the bottom. Again, nice thick metal. Sony they build good stuff. Oh yeah, and then there's the rest of the screws. There's the ballast. We'll look at that ballast. I wonder if it's a Rubicon ballast. JVC uses Rubicon brand ballasts, and they're crazy expensive. Alright, we got another screw here. And like I said, the power factor, the power supply to the ballast, that was that wire. And let's see if this lifts out. We will have to unplug the lamp connector. And I'll have to, the ballast control wire. Here, does that pop off? Let's see. Oh, okay. Man, Sony they build stuff so nice. Instead of, you know, using an ugly, annoying clip or a screw to hold this down, they have one of those little plastic, you know, I forget what these are called, but the little expanding clip. There we go. You know, that thing right there. Is there really such a thing as an unhealthy projector obsession? My wife may agree with that, but, you know. There we go. All right, so I unplugged the control. And then let's unplug that's the feed to the lamp. So here's the ballast. I'm trying to see if they have a brand listed on it. They're using discrete MOSFETs, so this is probably not Rubicon. Sony maybe? Let's pop that screw out. And we'll see. And again, I know I keep saying it, but this thing's just built so nicely. So definitely hold on to this. I know it works. I mean, the whole thing generally works, at least for the parts I need. Doesn't say, but going by the part number, I believe this to be a Sony. Manufacturing date, 2013, 04/15, so April 14th, 2013. 8 years old. 8-year-olds, dude. Alright, so put that off to the side too. Save that. Let's see, one more screw. Metal? Yes, metal free almost. What's the holding it? Oh, okay. There are a myriad of cables affixed with clips to the back side of that. This is, I think this is an LVDS COM cable from the main board to the optical engine here. Let's see, I got those two unplugged, got that unplugged. I'm hoping that this might be the point where we lift the optic assembly out. Anybody who's ever taken a car engine out knows the fear of not having a wire or hose disconnected, and I'm kind of feeling that now. All right, so the lamp wire is disconnected, but it's routed through, so that has to come off. We're going to take it off on this side. Hopefully I'm not blocking the camera. There's the connector. Route that out. Let's see, does that, you know what? Oh, actually that might be fine. What do we got here? Ground strap. Yeah. Sometimes Sony will do stuff like all the silver screws have to come out, or all of the black screws, depending. And I'm going to pay attention to that, because so far all the white screws have definitely held in things that had to be removed. Might just be coincidence, but Sony's kind of cool like that. Let's see. It's coming up. Nothing on this side, it seems. And then on this side, we have these guys. Let's unplug that blower fan. Unroute it. All right, let me just set that here. All right, let's see. Okay, I got a few down here. Then what do we have, a door switch? Or is that just tangled? Yeah, we have the door switch right there. And, oh, come on, wire. Oh, the keyboard wire is my issue at the moment. And then the fan wire. Now, not my issue. Where's that gray fellow go? Okay, right here. There we are. There we go. So, there's the optical assembly. Ooh, 9 people watching. Cool. Wow. I hope you all are having a good day. It's kind of nice over here today in this part of the world. Anyway, there's the, that's the image engine, optical engine, whatever fancy name we want to give it. Video comes in here and then goes through this THINE chip. Don't know what that is, but clearly something that has lead length importance. You can see how those traces are wiggly because they need to be the same length for reasons. There's videos out there that explain that way better than I could at the moment, but that's on purpose, the wiggly traces. Then after that, it looks like, I think this is RAM. Those chips, I'm guessing. I didn't look them up, but how they're configured and what they look like, I suspect they're RAM. And then these heat sinks, these have the drivers for the LCOS liquid crystal and silicone elements. It's kind of like a hybrid between an LCD and a DLP chip. It uses liquid crystal to reflect the light. And personally, I think LCOS, DILA, I think those are some of the best looking pictures out there. And it costs it when you see what these things go for. So I'm going to set this back over here and totally block the camera, because this is the goal. Can you change light source from lamp to LED? The short answer is no. The long answer is yes, but you'll be very disappointed. The problem with using an LED, like a standard, like a cob, one of those LEDs you see everywhere for, $20 or $10, the phosphor on top of that LED doesn't give you the right color components when it's split up inside the prism. Like the actual LED doesn't have the right red, blue, and green color components in it. Now, in theory, if you got an RGB LED, that might work. And I've always wished I had time to try that, because I have an LED sitting aside waiting to try that with. I think an RGB one might work. You'll see a lot of those cheap, $200, $100 Amazon projectors. They have the single LED source in it, and the color's just not good on those. Hey, people buy what they need to buy, but I have my opinions, so, But anyway, back to this fella. We're going to get the main board out now. No? Almost? Let's go this way so you can actually see. So, main board itself is this guy. HDMI inputs here. One goes through a chip, and I think that chip handles the oh crud, what is that called? There's that not MTD. I can't remember the name of it. It's like supports screen mirroring, that protocol. 3 letters, begins with an M, eluding me at the moment. And then we have a normal HDMI processing chip. It's actually made by Lattice, which is interesting. They make FPGAs, which are pretty nice. Then under here, I'm not taking this off because you can create a world of trouble. But under here, there is the main processing IC, which then which has low voltage differential output, which then feeds through this crazy flat ribbon cable, coaxial ribbon cable. There's like shielding, and I'll bet you just this cable is probably $100 if I had to guess. Maybe not, but it wouldn't surprise me. And then we have ballast control here. That's that. Let's unplug that and plug that. This is low voltage in from the power supply. Unplug that. And then this is to the wireless card. Unplug that. All right, we have the fans and everything unplugged there. So to take the board out, 1, 2, 3, these screws come out. Because there's a metal frame. Those come out. Now, is that part of the bottom? You can see it's kind of a metal tub, but it looks like... See, I can't tell if this piece and this piece are connected or if there's a gap. What I'm hoping is that when I take out 1, 2, 3, 4, this metal bar and that plate come out. Worst case, I got to keep going and get the rest of that stuff out. I'm still going to do that, but I'm hoping that that this tells me what I need to know, because I actually need to do this again on another projector so that I can put this in. All right, so I noticed when I took that last one out, I saw it shift a little. Maybe you guys saw that. So let's see if... No. Nope, not coming up. Not coming up. No other screws, not there. All right, well, let's try this then. Let's go this way. Let's take out 1, 2, 3. Who remembers that? And then get my 5mm, because we got to take those fasteners off the serial, that RS-232 port. There we go. Yeah, I think that did it. All right. So the metal plate stays in place. Those fasteners come out. Those guys come out. Those 4. And then there we go. Ta-da! Oh, come on. There we go. There we are. There's the main board. That's $1,200 for one of these silly things, for a new one, you know. The reason I have this projector is because I need one, and the cost of a used projector with a secondary unrelated issue ended up being much cheaper than buying a brand new main board, which would take 2 to 3 weeks to get. No real warranty on it. You don't really need a warranty for the customer, but anyway, this ended up being a much more cost-effective option because now I also have a ballast. I have an optical assembly. We have fans. Heck, I even have a decent lamp here. Good old Philips UHP. So this main board, give me a second. I need to go put this somewhere safe. So one moment. The heck did I put my... Here we go. All right. Safe over there. All right. Thank you for waiting. There we go. So now main board's out of the way. That's good. Let me set the power supply and ballast over here. Let's get the fan out. This is the power supply fan. That is how the keeps the ballast, how the projector keeps the ballast and that low voltage supply from getting too hot. And now we can actually get the lamp wire out too. There we go. Just kind of unthread all that. I'm going to leave this as an assembly. Now I may end up using this in another projector if the specs match up, but you know. Hey Carl, how you doing, man? Good to see you. Let's see. What's next? What's next? We got this. Get that out. Get that out. Alright, we'll save that wire. I figured a teardown would be a good test for a live stream. I thought about doing them, and I don't know. I'm not like Mr. TV or anything, but I thought it might be fun, and it was seemed to be a good, just seeing everything kind of lined up. So I said, you know what, I'm going to go for it. Of course, I sent my wife a message letting her know, so at least I'd have one viewer. But now I have like 11, and that's just kind of blowing my mind, to be perfectly honest. And I know my videos have been a little slow lately because I've been jammed up here. Work's been just kicking my butt lately. And they're probably going to be a little erratic through the holidays, but I've got a ton of stuff. I've got an Optima video, oh geez, a couple BenQ videos, Ike, a bunch of stuff. I just record everything that I can, and then I try to edit it up the best I can. And I finally signed up for what is that, Adobe Premiere. So hopefully that'll. I like Adobe Premiere better. I've been using like cheap editing programs, and they're fine. But I have an old background in TV production, so I kind of like the way a real editing system looks. So Premiere reminds me of that. Here's the door switch. Just a little micro switch, nothing special. Save that harness. Here's the lamp connector. This is what is known as an M6 lamp connector. You'll see these in Christie and Barco and a few Mitsubishi, I think. They're different from the, oh, where the heck is it? From the M1 is the one you see a lot. Where the heck is it? I just had one. Oh, whatever. The M1 is the like black connector you usually see that kind of looks like this. But anyway, we'll get back to this. It's easy to distract me. All right, so we'll take the metal assembly for the power supply out. Unthread that wire. Unthread that wire. I'm going to keep everything except this bottom chassis. And probably this metal thing. I don't see a point in saving it. Now, to be clear, when I say throwing it out, it's going to be probably about a month. Because if I throw it out right away, I will have a need for it. So it'll go on a shelf near the door, and that's where it'll sit for about a month. And if I don't have a use for it in a month, then it'll make its way to the recycling bin. This I'm definitely saving. This is worth quite a bit, you know, parts-wise. And these silly things, these little white wire clips. Sony uses these in all of their gear, even their stereos. So I always pull these off and save them. Especially since for like these guys, you just turn it. It pops out. So I'm going to keep all that stuff. I always keep the screws. Sony equipment is probably the best equipment out there to get scrap parts from. Like they use good parts. They build with good parts. So when you scrap them down, you get really good parts. Back when I used to repair the Sony Trinitron TVs back in the day, I always kept their parts. Sony Trinitron TVs were just a gold mine for useful parts. They use really high quality capacitors and the picture tubes and those things. To throw them out, I'd have to break them. And I would get a 30-pound sledgehammer, wail on it until it would finally start to crack. So anyway, I'm dating myself a little here. This switch is for the filter, and Sony being Sony, they even mark it on there. I don't know if you guys can read that. I really can't tell how clear the picture is because I'm to the side and you guys are over here. So, but I think it's good. It looks good. When I did a test on my computer, it looked good. So, what do we got now? It's good. Nice. All right, then we're gonna get the power plug. Get that out. The receptacle. That'll go there. Pull this one out too. And then big screw. Big screw. And these are all metric. Any of the fine thread ones are metric for sure. Those are probably 6mm metric, and those are actually good for mounts on smaller projectors. Those are 6mm. We got one here. There we are. Huh, Delta. Fun fact, that company there, Delta, they make a lot of projectors. Vivitech, some BenQ, some, like I should say parts in BenQ, and some parts inside Optima. But Delta, yeah, Delta Electronics, they make a lot of projector stuff. I'm trying to remember a model that would be a Delta, like TH1060 Optima, I think, is made by Delta. Also, Polyvision, I believe, is Delta. You know, they're a ODM, OEM. You know, they make it for a company and stick their name on it, whatever you call that. Got that steel piece out, and again, I like that. That's heavy duty. Does that come out? Where's that? No, that's, I don't really care about the little barb clip ones. We'll let those go. So that's good. This is finished. And then let's just take a look-see at the optical assembly, and then probably going to wrap up the video around there, maybe? I don't know. We'll see. It's, I don't even know what time it is. Getting close to 3 Eastern time, something like that. I can't check the time because it's on my thing that I'm recording with. So, let's take a peek at this. How do I want to do this? I don't want to take it apart too much. I just want to take it apart enough to show you guys. So, the lamp, we'll do it this way. The lamp goes in here. Like that. It would plug in and get power to it. So when the lamp is shining, it's shining through here. But we can't really see that because the shroud is in the way. So let's pop the lamp shroud out. I'm probably going to put it back on before I store it. I can't see. There we go. All right, so now that should, yeah, there we go. So it shines in through here. There is a special filter, optical filter. It's identical to the filter that they put on DLP lamps. You can kind of see it if I change. There you go. You can really see it. That's that IR UV cut filter that keeps the infrared light from getting inside and cooking things, because you want to keep as much heat out of here as you can. So the light then shines into there, and you can see there's a all sorts of little reflecty bits in there. That is a fisheye objective array. There's a fisheye lens and then a fisheye target. That very LCD-like. The light comes in and it starts getting split up and collimated until it hits a set of, let me see, maybe we can even see them. There should be some dichroic mirrors. Mirrors that reflect certain frequencies of light and reject other frequencies. If you've ever taken an LCD apart, you've seen those inside the main, optical path of the LCD. Oh, one more. Yeah, I think we should be able to see what is holding it. Clip. Come on. Come on. A little more. There we go. Oh, all right. Yeah, so these are ducts. This is just directing air. And is that a screw down there or a clip? Just a clip. All right, so this should, there we go. We can't see squat. That's kind of disappointing. Can we go in through the other side? See, now I'm invested in showing you guys, so let's do it. We're going to pop these clips loose for the LCOS. And I will say, this can kind of be a gamble, especially on Epsons. These flat flex connectors can break really easy if you just bend them a teeny bit too much the wrong way. Sony's are a bit more robust. I'm not as worried. In fact, some Epsons have Sony parts in them. They tend to be a little more robust. So let's pop these screws out of the image drive board. There we go. I like that name. That sounds proper. Sony probably calls it like the Sony board or something. There we are. We'll take that out. Now we can really see what's going on here. At least as much as we're going to. So again, light comes in here. In fact, we'll use my fancy flashlight. It'll light it up a little bit. So the light goes in there, and we'll turn both flashlights on. Now we're running in standard mode instead of eco. So light goes in there, and then there are some dichroic mirrors as you can see, starting to split the colors up. There's our blue channel, our red channel over here, and our green channel. You can kind of see the glass. The mirrors themselves and the prism is in here, but I don't think I can safely expose that without making a big mess. I know there's some screws here, but I think if I take those out, that will be a problem. However, I'd like to show you this. This is the Lcos block. Can we get that out? Not really. I was kind of hoping there'd be a screw coming up from the bottom. I'd like to take that out and show you. Not really. Let's see. All right, for you guys, since you guys were all cool enough to put some time aside out of your busy schedules, taking care of your own projectors or making dinner or whatever else you got going on, let's go for it. Like I said, this part isn't really needed for my repair, so if I accidentally screw it up, it's not the end of the world. Oh, cool. All right. I didn't break anything. Yes. I always like when I don't break things. Now you can really see what's going on. Okay, I'm glad I did this. So, light comes in. You can see we have mirrors here. Dirty too. You can see the that's one of the dichroic mirrors. Lets the blue through. It lets blue through, but it reflects red and green the other way. The other side lets green through, or lets green and red through apparently, because we got red up there, and reflects the blue the other way. And that's really what they do. They're set up to reflect only certain colors certain ways. Then they get to the Lcos module right here. Can you see that? You can kind of see it. It kind of looks like a DLP chip or an LCD with a mirror behind it. It's probably the best way to describe it. Yeah, look it up on you know, the usual places if you want to see how Lcos truly works. It's a neat technology, though. It's very similar to DILA. It's interesting that JVC and Sony both use similar technologies that way. So, yeah, that is, I guess, the teardown of a Sony VPL-HW45. If you guys have any questions, I will go back and check the comments afterwards. I'm sorry that I couldn't reply. It's kind of hard to, you know, type and do this. I'm sure you all understand. I really do have a cool bunch of subscribers. It's kind of neat. I never thought anybody'd really be interested in this stuff, and it's, I don't know, makes me smile every time I see comments and stuff. So thank you guys a lot. So yeah, I don't really have a fancy way to wrap this up, so we'll try that thing where I say thank you for watching, maybe. I don't know. But really, thank you guys. Thank you guys a lot. Thanks for watching my first live stream. I will have some videos up in the next, I don't know, I have to ask my wife when I'm free enough to do it. Just teasing. No, she's actually really awesome. So, yeah. I don't know what to say now. So anyway, thank you guys for watching. Have a great rest of your day, and take care and all that fun stuff. Oh, hey, Mohammed. Good to see you, buddy. Hey, and Tyler, take it easy, buddy. I'll talk to you. Everybody take care, and cheers.